In this lesson, we are looking at how to build a simple storage Dapp. So far, we have seen the functionality of how to connect your wallet. Now, in this particular video, we are going to take a look at the rest of the functions, that is being able to read and write a variable from and to the blockchain. So let's get started. I have already have my repo. I hope by now you have been able to write your init wallet function, which is the function that is used to connect your wallet. The next function that we're going to be taking a look at is read number. This is a very simple function where you are setting the retrieve loader to true, which is, retrieving the value from the blockchain, right? So if you deploy your own smart contract and are able to build this front end for it, the first time when you retrieve the value, you should get 0, right? Because the default value for an integer is going to be 0. The next thing we are doing is being able to get a signer using the provider variable that we have already created. So the provider variable is set using set provider over here, and this sets the provider to the instance of the wallet that you have connected, right? Whatever is the JSON provider. And from the provider, you can get the sign. And this is where we already looked at the functionality of ethers. That is, ethers library can be used to get an instance of the contract that you have deployed. So you can give the contract address, the ABI, and the provider that you have chosen to work with. Make sure that the provider is in line with the contract that you have deployed. For example, if your contract is deployed on Goerli, then you should be connecting your Dapp to a Goerli wallet that supports Goerli, right? So once you have the instance of the contract, you can connect it, and you have to pass the signer as a parameter. And once you have this contract with signer, now you can basically read the variable that is there as a part of that's there on the blockchain, right? As a part of your contract. Now the contract with signer is required here because it's not actually required, because read only operations you can technically do just with the provider. But having the signer gives you the ability to be able to read and write, right? So that's why, just to make sure that you are able to read and write, you can use the with signer, right? So once you have this contract with signer created, you can call the function, that is the read function. You can store the response, and you can log the response, and of course you can also set the variable to this particular response that you have received, right? Now, similar to that, the write function is also fairly simple. You are extracting the signer, you get the contract instance, and then you build the signer connect using the signer. This is required in this case 100% because the write function, as you saw, requires you to sign. So you need the signer instance in that case. Now, while you are going to write, this is the function write num, and you need a number, right? So this is where your entered number comes into picture. The entered number variable is set when a user enters the variable in the HTML markup. We'll see that very shortly. And you can send the entered number, and you have to wait for the transaction to take place. And once that happens, you can console log the response, and you can also give an alert that this particular number has been stored successfully on the contract. You have the use effect, which is common in React. You can see that it accepts a function that contains basically, effectful code. That is, every time you sort of refresh, right, and you load your Dapp, you're going to be getting certain things, like when you change an account, right? So there is a change of action that is happening. So you say that the new wallet has to be, the new address has to be adjusted accordingly. So this is where the use effect comes into picture. You can see that the HTML is again very simple. It uses Tailwind CSS, so you can sort of modify that accordingly. However you want to build you have the connect wallet button, where you have the wallet status, whether it is connected or not, as well as the address of the connected wallet. And then the comments that this action receives save number from the smart contract, so that is the read operation. And you can see that the stored number is being displayed here as the stored number, right? So it should ideally initially be 0, not because of the default value 0, but if you have deployed a new contract, then initially the number should be 0 whenever you try to retrieve it. And the second one is the write operation. I mentioned that the entered number, right, it will be set. It will be set whenever you are in the input box, when you are entering a certain number. That number will be set as the entered number, that is the target value. And this is what will be reflected when that particular function is being called. So if the wallet is connected, then you can write this particular number, because only you need to sign the operation, right? So without connecting the wallet, you cannot perform this operation. So you have this, and then you have the store button. So you can see that it's a very, very simple sort of interface that is for complete front-end beginners. And this is a great example for you to get started on your front-end journey, to be able to create a full-fledged Dapp, right? You're already a Solidity smart contracts expert, but you also want to understand the other nitty-gritties surrounding decentralized application. And this is where this entire module is going to help you to figure out, like, how does it work, right? You'll have to work with front-end developers as well in your career to provide them as to, inputs as to how they can connect with the contracts. Even in that case, it helps to understand, how the front-end code is written, what are certain things that they might be looking for. Like over here, we are creating a simple transaction, but you might have to create a more complex transaction with certain parameters like gas fees and all of that, being able to modify that and things like that. So that is why I focused on building this module out for you. And I hope that now you are confident enough to be able to explore, to start building your own decentralized application, both using Next.js, Tailwind, CSS, and your Solidity smart contracts, of course.